Hello class, I'm gonna record out Unit 1 exam solution or explanation for you to review. So I'm gonna go backward since towards to the end it's harder. So the first question is talking about runs and wins in baseball. So this here, hopefully you guys read the question, and the problem is given the regression line already, which is the y hat equal to 34.85 plus 0.07x, where this is what we call response variable, and this is what we call explanatory variable. So this is what we call a slope, and this is the y-intercept. Okay, any term that has no variable term is called y-intercept. Any term associated with x in it, it's the slope multiplied by the x. So obviously you can answer this question pretty quickly. Yeah, that this is the number. The run is the explanatory variable. You might get a question that that it's asking for responsive variable, then you might need to choose number of the wings for the answer. But this is the general structure of the regression equation. So to interpret the slope, we talked about that before. That slope is rise over run, and which is 0.07 over 1. So we say that for every additional run, the expected change in number of the wings will be changed by 0.07. So the answer will be here, this one. For every additional one more run, the change of the wings is not change. So run here is, this is wings divided by runs here. So this is the number of the wings divided by runs. So for every additional one runs, increase by 0.07 wings. Okay, so that's number B. And for C, the Francisco Giants won 88 games, scoring 665 runs in 2014. So this is telling me when this is what we call actual observed value. Okay, if this is given observed value, and then you want to get the predicted number or expected value. So expect, because we use a regression line to generalize the data. So we want to get the expected value. So expected value, it is this equation is the expected value. So if I also plug in 665, what is the expected value? If this never happened, what is the expected value that I should get? I should be able to win if I run at 665. So it'll be wins equal to 34.85 plus 0.07 multiplied by 665. And then if you put that into your calculator here, this one should give you 81.4 wins. That is here. Then the residual will be equal to the observed observed minus the expected. Okay, expected, which equal to observed was 88 or actual minus the expected, which is 81.4. Then you receive the residual about 6.6 for this problem. 6.6 gain wings in difference for residual. So this is what we call expected, and this is what the actual value. We can actually use this one to go back and calculate whatever those observed value and see how much the residual between the actual and the expected. So this is what we call regression line. That's number 214, the last problem. You might get a slight different problem or numbers, but the idea is the same. Okay, that's number that. And then number 206. So for this problem, they give you those data set, and then you can use stack key to get the regression line, where x is explanatory variable, y is the responsive variable. Now you can use your calculator. In this case, I'm going to access the stack key to calculate this. So to use this, I'm going to use two quantitative variable, and then I am going to edit the data. Then to delete the data here, and I just type in x, comma y, x, comma y, and then 10, comma 110, and then 20, comma 107, and then 30, comma 94, and then 40, comma 86, 50, comma 86, 60, comma 87. Then once you type in all the data, and then you tell that the stack key that you have a header, your header is x and y. So then you click OK, and then you can see that the sample size is 6 data point 1, 2, 3, 4, 5, 6 has a slope which is negative 0.531. Y-intercept is 113.6. You can put a regression line which is negative because the slope is negative. So you're expecting decreasing trend for this one. So if this one is simply you're gonna just answer figuring out the regression equation, which is 2 decimal place for the slope and 1 decimal place for y-intercept. Make sure you round it correctly. So for this one, you will take a slope which is 0.53, and you don't round this one here. So make sure you put 0.13. Now this one here, you will put 1 decimal right here. So you will take a 113.6. This one, use a stack key, it's pretty quick. You can also use your graphing calculator. So that's number 206. Now let's go back, continue to do 201 here. 201 is two variable a defined regression equation is given, one data point is given. So BAC is what they call blood alcohol content, which is a percentage of alcohol in your blood. So if you drink any alcohol, if you drive, and then if you get caught by the cops, and the detector, the machine that they're gonna use it is to measure that BAC, how much of the alcohol in your blood, the percentage in your blood, and you cannot get over 0.08, which is 8% of your blood. So that's how they determine if you are drunk or not. So BAC regression line is given, which is the responsive variable. It is BAC equal to the number of the drinks. So the data point, they're giving you a actual or observed value. Observed, anytime they give you a value has a observed value or actual value. It is 3 drink contains 0.08. So your predict value of this point, if you drink 3 using this predict function or regression, will be BAC equal to negative 0.0125 plus 0.019 multiplied by 3. Just to compare the actual to the actual 3 drinks, you have a BAC of 0.08. Then I'm going to put into this one the regression, see how many how much of the BAC do I have in my blood. And if you calculate this one, it will be 0.0125 plus I believe it's 0.057. And then if you calculate that, the BAC is equal to 0.0445. Okay, 0.0445 for this one. Then the residual will be residual will be equal to the observed value minus the expected value, which is 0.08 is my observed BAC minus the 0.0445. So that's how I get 0.0355. Okay, that's the here it is my residual, here is my BAC. Double check your answer. I think 0.057 minus the 0.0125, it is equal to 5, 4, and then 4, 0.0. Yep, checked. So that's the BAC, that's number 8. And then for the slope, we talked about previous problem. For every the rise over run slope is 0.019 over 1. So it's always going to be y over x, right? Which is rise over run. So which is BAC divided by drinks. So for every additional 1 drinks that you get, the expected change of BAC will change by 0.019. So this is this. So you need to define what's on the top. Usually 1